And this speaker is the founder of Fast Forward Labs, which is a machine intelligence research company, and the data scientist in residence at Accel. Please welcome to discuss how to build things that actually work. That's a big question, isn't it? Please welcome on stage the co-founder of Hidden Door, data scientist in residence at Accel Partners, Hilary Mason.
Thank you so much.
You're welcome.
Hi, everybody. I'm Hilary. I'm very excited to be here. Before I hop into this, I know this is the end of the day, and I'm sure, like me, you all are lagging a bit in energy. So if you want to go grab one last coffee, another brownie, let's try and keep the energy high. And so in order to do that, I promise to say thank you. A bunch of provocative things in the next 15 minutes. That you can then ask questions about or argue with me about, and hopefully will give you something to have a lively debate about once you step out of here and go to a pub or wherever you're off to after this. I did want to introduce myself, so as you can probably tell from my bio, I have a bunch of different kinds of experience because I started as a computer science professor focusing on machine learning about 20 years ago, and then started working with startups, including in social media. Was the chief scientist of a company called Bitly about 12 years ago. Have also worked with local city governments, have been in startups. I had a company called Fast Forward Labs that was acquired by Cloudera, where I ran their enterprise data science machine learning business. And so my ADD in my career is to your benefit, because I'm going to speak today about all of those perspectives in building AI products that actually work, because it's really hard. So before I get into that, I'm actually going to ask a question of those in the room here. How many people are working on building some kind of AI product right now? Right. About half the folks admit it. I don't know why the rest of you are here, but I'm glad you are. So maybe we'll convince you to join us in the next little bit. One of the things I've learned in working across many communities and many constituencies is that you actually have to have a shared idea of what words you are using and what your vocabulary means when you walk into a room. And we've been here talking about AI for the last 2 days, but I have not really heard it defined. And so I'm going to start by talking through the vocabulary that I'm using, maybe is the first thing you can argue with me about. And then sort of branch off from there into how we see this done well, and also where it goes a little bit awry. So if we were having this conference 12 years ago, it would be World Summit Big Data, which I still put in quotes because nobody has ever defined to my satisfaction how big has to be. And that was really about being able to get all of your data in one place and count things in that data without additional specialized infrastructure. So it was the commoditization of something that we'd been doing for quite a long time. So none of it was new, but the fact that you could now apply it not just to incredibly high-value problems, because it was already being used in operations research, actuarial science, certainly in finance, but you could now apply it to very trivial problems was a transformative change. And that opened up a whole lot of what led to us being here today, because when you can count things, you can do it for a reason. And then you have analytics or business intelligence. You can count things to actually be informed in your day-to-day operations. That was also a change, being able to ask speculative questions or do R&D. And then when you can count things cleverly. So you can build predictive models to let you predict things that you can't observe directly or that haven't happened yet. And now you're doing data science. So you're building predictive models of things and perhaps learning them either to inform people or to inform machines to make automated decisions. And then you have feedback loops, and now you're predicting things with feedback loops. Now you're doing machine learning. So your machines get better with the introduction of more data, and they get better over time. At least that's the ideal. And then we have AI, which brings us here today, which is a term that can mean all of these things. It is a stack all the way up. And came into popular usage because of the rise of deep learning as a technique, which opened up a step function change in what was actually possible with AI systems or really with any of these technologies. So they're all interrelated. And AI is also blue because it's the color of the future. It's where we're going to go. But I think one of the most important things to keep in mind in shifting to think about building great AI products is that we are shifting from a world in which most of our products are deterministic, as in we are designing software systems that we know are possible, to probabilistic, where we are now designing products that we don't know what it's going to come up with. We may know the range of outputs, but we don't know what the distributions are going to be. We have to handle accuracy issues. We have to communicate that to the users of those products. And so to that end, I've put two of my favorite data products up here. One is a local weather prediction, though, of course, when I showed this slide to a friend of mine who lives here, he told me there's an app everyone in Amsterdam uses that predicts the rain much more accurately than mine. So I'm sure you all have that. But it is being able to take information about ranges of uncertainty and visualize it in a way that somebody can make a good decision from this information without having any understanding of the technology that's behind it. So in the case of Google Maps with the traffic view, you do not have to know that they're getting real-time data from people's phones and devices out in the world, that they're integrating that with historical predictions, that they're visualizing it over the cellular network, which, by the way, I just hop off the plane and my phone works. It's lovely. They're making that probabilistic data useful, and then they're having those feedback loops. So this is the major mindset, and it's also the thing that I find that folks who want to move from traditional product design or software engineering into building AI products struggle with the most, is that the architectures change, the systems change, the stack changes, and the product development changes, and the UX, it's everything. That's why it's exciting. So this is my very provocative slide for today. Why is this hard? Well, it's hard because it's not hard because it is by nature any harder than anything else. It's hard because our existing organization systems and processes are not set up for building great AI products. They are set up for building great products or great businesses, or at least good operations or good process. But we find that, for example, processes in software engineering, like agile software development, completely fall down when you try to apply them to machine learning systems. And we find, too, that the incentive structures in all of the economies that influence where this work is being done are broken. So in academia, if you don't have a system that works against the correct metric or the correct benchmark, you can't publish it, even if it actually works for some real person with a real use case. You also can't just go out and buy this stuff, because as a large entity or large enterprise, you have your own data that can inform your context and your decision, but nobody else has that data, and they can't build that product for you. And startups tend to be new, young companies. Even with the domain expertise, they don't necessarily have the data, and so they can't always just build a solution and sell it. And so a lot of the innovation methodologies that we've been used to working in other areas break when we come to AI. You're all going to argue with me, I hope. But there is hope. So let's get into it. So how do we do this well? The first is a relentless focus on what problem you're really trying to solve and what good looks like. And that may mean quantitative error metrics for some sort of algorithmic thing you're trying to design. But more likely, it is actually figuring out where the human value is going to come, framing the problem correctly, making sure that you're not thinking about just replacing people with shell scripts, but you're thinking about augmenting decision-making with better information in context, visualized appropriately. And as I say things like that, you may realize that most of the most useful AI products that we use today don't have purely quantitative metrics for success. And this is even very technical products, like a search index, for example. It's not purely quantitative. It means thinking about how you're going to approach solving problems in the spectrum from things that can be largely commodified and solved in a generic way, all the way to opportunities that you may have, but that other people cannot possibly solve for you. And this one I wanted to highlight for this audience, because especially in larger, more traditional enterprises, I see this data product gap where folks are looking to buy a solution, but the solution can only exist for the generic form of the problem. And when they actually do a POC or try to implement it, it breaks. So it means you have to have a certain amount of this expertise in-house. It has to be part of the strategy. And you can't just use money to get your way out of this problem. I'm sorry, it's not that easy. And the next thing is to work on the right problems. So we find that in organizations, it's usually best to find something where you're spending a lot of money, but you can use some automation to make a process more efficient, and then you have a thing that has made money or reduced costs, and that's a win. And then you get organizational permission to go out and actually build new things. But the new things are where all of the value really is, because they don't have their ROI is uncapped. The other thing I wanted to highlight on this is that you can make tiny improvements at large scale or order of magnitude improvements at small scale to get value. But making tiny improvements at small scale is a waste of people's time and energy, and it's better not to bother. Data scientists are very expensive, so spend them wisely. Oh, and the last thing I'll say is this is an article I wrote that was in Harvard Business Review talking about the difference between a mediocre data science AI strategy and a good one, and how a good one builds on itself. And so I wanted to tell a story of what this looks like done well. So this is a story of a customer service center for a bank in the United States that we worked with closely for several years in my last company, and a bunch of robots. And I say they managed to take something that nobody thinks of as an AI product, frame it as one, and then use technology efficiently in a couple of places to solve critical problems at scale. And so what they did was this. First, one key difference between these folks and most of the other people in similar situations I've met with is that they actually run their customer service call centers in-house. So the folks in the call centers are actual employees in the same office building as a lot of their staff. And they took a year of transcripts of people calling in. They used an outsourced service. So this is a great example of something that should be commoditized to do speech-to-text translation, got all of the transcripts of that stuff, figured out what people were calling about, so clustered all of that text, were able to identify the different clusters of complaints, were able to get an expert from the call center staff to come in and say, oh, this is this issue, that's that issue. We're then able to tag it with what the resolution was, so whether the person ended up calling back or not, and what the customer service agent who helped them actually did. Then they went and got all the account data from what had happened in the person's account before they had the issue. And then they were able to say, OK, for this set of issues, we have these remedies that seem to work efficiently, these that don't. Let's make sure we build a recommendation system so that our customer service agents are able to essentially leverage the wisdom of their entire cohort to make better, faster decisions, get customers off the phone faster, and have better outcomes, which worked. The second thing they did was that they became proactive. So they went and did predictions for the issues that they could detect were likely to happen in a customer's account where there was some kind of way to solve it without actually getting on the phone. They would proactively reach out and say, hey, we think we're seeing this. Would you like us to make this change for you? And that also increased customer happiness because it let people not have to call into a call center. And it also reduced their costs dramatically. And when I say dramatically, we're talking about multiple percentage points across a large call center, which translates to millions of dollars a year. What I love about this is that they were able to get the data, make really smart decisions about what to build in-house, what to buy, to actually have feedback loops, to involve the domain experts in figuring out where the data would be most useful, to frame the problem as one is taking that collected wisdom through data science and making it useful to every team member. And it gets better over time. So that's one I think was really successful. And I have 9 failure stories for everyone that works that well. But we don't have time for that today. In order to wrap up this, I guess this part of the talk, just wanted to say that there has never been a more exciting time to be building products and businesses around AI. The fact that it is chaos and undiscovered means that we all get to invent how our professions will look, what our professional roles look like, what good looks like for our products, for our industries. It's a very exciting time. We've heard today about many cautions and issues, and we all have to keep that in mind, building responsibly, but it's still pretty cool. And I wanted to end by telling you a little bit about where I see the future going. This is my new company, so it's a startup. We're 6 people, including one who lives here in Amsterdam. And we are building a multiplayer game that allows you to explore interactive, immersive, narrative entertainment. So if anyone here has ever played a role-playing game like Dungeons & Dragons or another tabletop game like that, where you have a person who guides you and your friends through stories, this is something we're now doing with AI as a facilitator. And we have framed the AI not as a creative thing in itself, but as a creative tool for players, who are mostly tweens and teens, so younger folks, to be able to have at their fingertips. So they're no longer paralyzed by a blank page. They can say, I'd love my story to go this way. They can show off for their friends, explore identities, and explore worlds, and create new worlds for them and their friends to play in together. And it's exactly the kind of product that I'm most excited about, because it reduces cognitive drudgery, enhances our creativity, and creates fun, exciting memories for all of us with our friends and family together. And I think we'll see more and more AI products that look like ours. And with that, thank you. That's it.